Okay, thank you and welcome to today's class. So yesterday we discussed about the first method of performing linear regression, and it was that is using. I said three. We have three methods, okay, of maybe practically doing what? Doing linear regression, or for three methods for finding the coefficients, okay? Three methods for finding coefficients of what? Of our regression line, okay, or of our regression equation, okay. So with that, we have the first method. We used uh, scatter plot, scatter plot method. Okay. Today I want us to do this. That is using the second method, which is using analysis ToolPack. Okay, and then the third will be using Excel what? Excel functions. Using Excel functions. So these will be our that is three methods to find now the coefficient of what? The coefficients of the straight line. Okay, good. So maybe let me just redo the graph which we used yesterday, or which we did yesterday. So I know you remember the process. If maybe you do not get it clear, then maybe you can follow with me, or maybe you can go and check that is the the class recording which I shared yesterday. Okay, so we have to insert our what? Our scatter plot, and to do so, you highlight your data. Okay, usually highlight your data, then go to insert recommended charts, then go to all charts, and then go to XY scatter plot. Okay, then under scatter plot, you can see we have two scatter plots, but you can see this is mostly showing us that is the data points trend. Okay, that is the data point trends, and in this case, you can see the rainfall amount. It's on the what? It's on the y-axis. Okay, and the rainfall amount. It's not that is the rainfall amount. It's not what we are trying to what? It's not what we are trying to predict. Okay, so we will use now the scatter plot, which now has the umbrella cells on the what? On the y-axis, because our objective here is to predict what? It's to predict the amount of umbrella cells with change in what? In the amount of rainfall. So with that, we are going to select this one, and then uh, the second step is now to insert the that is the linear graph. Okay, all the that is the equation of a straight line. Okay, so we are going to use the chart elements here and then add a trend line. Okay, so for trend line now, it's upon you. You can go with linear, you can go with the, but because we are talking about linear equation, okay, we have to use what? A linear, that is a linear that is trend line. Okay, so with that, you'll go to more options, then under more options you can select linear. Okay, we'll need the what? We'll need the intercept, or we will need the equation on the chart, and also we need that is to display what? To display the r squared. And I said in this case the r squared is what? The r squared, it's our coefficient of determination. Here it's our coefficient of determination. It's trying to show us how that is our model. It's fitting what? It's fitting our data. And you can see our model has fitted 91% of what? Of our data points. Okay. So with that, I also said you can always that is um, that is extrapolate. Okay, we can always extrapolate this line to that is to a point where it is cutting the y axis. Okay, for us to get now the right or the real intercept, y intercept. So with that, you can always also change that is the compound type or the type of the of the line graph. If maybe you want it to be a continuous, or you want it to be dotted line, or you want it to be a dashed line. Okay, so it's upon you. Okay, for my case, I want it to be what? Continuous. Okay, then after that I want to set like that is to forecast. Okay, to do some forecast both that is forward and also backward. Okay, I want to do my that is my forecast both that is forward and also backward. Then by what percentage? Okay, what percentage do you want to forecast your maybe um, your best the line of that is your line of best fit. Okay, maybe for my case I said I'll want to go with 100%. Okay, forward, and also 100% that is backward. Okay, yes, and 1% backward. So with that you can see now we've extrapolated our line, and you can see it is cutting the what? It is cutting the y-axis at negative what? Almost at negative 19, between 18 and 19. But you can see that is the y-intercept. It's on the negative side of what? Of the y-axis. Okay. Yes, so that's why you can see now our intercept will be a negative value. Okay, so with this you can even maybe try to check in case maybe you have a rainfall amount of maybe, let's say, this point you need or you are trying to focus the number of umbrella cells which you will make when the rainfall amount is at 250 millimeters. Okay, you can see you will sell close to that is 90 umbrellas. Okay, you can see you will sell almost up to that is 90 that is umbrellas. Maybe let me try, like I'm saying, January of the following year, the rainfall amount is at 250. Okay, so what will be the value of umbrella cells? So it will be something that is more than 90. It is something more than 90. That is to accurately that is find the value of what? Get the value of our what? Of our y. Okay, so with that I'm going just to use this formula. I don't want to go to the Excel inbuilt functions, but I will just take this equation of straight line. So it will be, we know y is given by 0 point, it is given by 0.4482. Okay, multiply by, what is our x? Our x is 250 now. Multiply by 250, then minus 18 point what? 915, and then we'll be able to get what? The value of what? The value of our that is of our umbrella cells. Okay, so you can see our value will be what? 93 umbrellas. Okay, so we'll sell that is 93 umbrellas. Okay, yes, that's all about it. Was just a recap of what we discussed yesterday. So I guess up to that point, no one has any doubt or has any challenge with the scatter plot method. Why? Our objective was to get what? These coefficients. Because if we have these coefficients, then it will be easy for us to do what? To do that is the forecasts. Okay? Yes. Well understood. Is that clear? All clear. Only two people. Three, four. Okay. Five. Yeah. We are all good. That's nice. Okay. Now let's go to the analysis toolpack. Okay. So for analysis toolpack, all right, just give me 1 minute to connect my machine. Just 1 minute. Okay, we are now good. Right, now let's continue. So I want us now to do that is or to find our coefficients using the second what? The second method. That is that is the best, if I can say, it is the best method. Okay, because it will give you that is a little bit of analysis of your model in terms of performance and in terms of that is reliability. Okay, so I'm going to that is I will go to data. Okay, take note of this. I'll go to data, then on data I'll go to the data analysis toolpack. Yes, I showed you how to use it last time. So after that, we'll go to regression. Okay, we need regression. So now with the regression, after clicking regression, you can either double click on regression or you can click and say okay. Okay, so when now you can see now we have what? We have that is the input range. Okay, the first input range is the what? Is the it's the Y range. Okay, what we are trying to predict, and then our second input will be the X range, which is our independent variable. Okay, then after that, you can see now we have labels. So in case maybe you highlight even yeah, that is up the okay, inclusive of the titles, then you will click yes, we have labels. Okay, if you don't want to include the labels, you'll just highlight what, the data only. Okay, let's maybe start with the data only. Okay, so we have input y range, so we need the input of y range. So you are just going to highlight, let me just a minute, I want just a minute, I want to remove this one. So I want to do what, I want to remove this that is additional data which I've included. So let me go back now to data, then data analysis, we have regression, then now we want to input our what, our range. Okay, so you are going to highlight your range, that is now the y range. Okay, you will select the y range, then we also need what, the x range, so you'll come to the x range and highlight what, highlight the data. Okay, then after highlighting the data, now you will go to the output. Okay, do you want your output to be on the, that is on another worksheet, or you want your output to be on the same what, on the same that is worksheet? Okay, we can prefer maybe to take it to a new what, to a new worksheet. So after that you'll just click OK. After that you'll just click OK. So after you click OK, you will get this kind of output. Okay, you will get this kind of output. Are we together up to that point? If maybe you are doing also from your side, I hope you are getting the same output. Maybe, let me repeat, maybe in case maybe someone did not get that clear. So you will come to data, then go to data analysis, then you'll go for regression. Okay, then after choosing regression, you will now have to highlight that is the your input data range. Okay, you can see we are that is we are required to enter input y range. Okay, so this is our y range. Okay, so you are going to highlight your range of data. Okay, then come to the x range, then highlight what, the x range data. Okay, then after that you are going to do what, you are going to say okay. Once you say okay, or you have to choose where you want to paste your data. If you want your output to be on the same page or on the same worksheet, you'll click output and then select the cell where you need the output. If you don't want that, then you can that is select your output to be in another that is worksheet. Okay, yes. So this is the analysis, all the our summary output. And this summary output, it has three parts. Okay, that is the regression statistics, then we have analysis of variance, and then we have what, the coefficient data. Okay, very correct. So let's start with the regression statistics. So with the regression statistics, you can see we have multiple R, R square, adjusted R square, and then we have standard error and observations. Okay, so for multiple R, remember for multiple R, I also, while we are talking about correlation, I said that another name, maybe when it comes to analysis, another name for that is coefficient of correlation, it's what, it's multiple R. Okay, so basically this is our what, this is our correlation. And as you can see, it is the same value which we got when we were what? We were computing correlation. Remember that when we said maybe correl, okay, that is correlation of the first array, okay, when we use the formula, and the what? And the second array, okay, you can see we got this value. We got this value. That is 0.95793. Okay, and you can see in our output, it is the same value which we are getting. You can see it is the same value. Maybe I can just copy this value. Let me copy this value to here. You can see it is what? It is the same value which we got. Okay, so basically this means it's what? It's the coefficient of determination, and coefficient of determination basically will show us how these two variables are correlated. Okay, so it means we have a high correlation, or we have a strong correlation, that is correlation between x and what? And y. Okay, meaning any change, that is any change in y, okay, will also trigger that is the same change in what? In x. Okay, yes, then we have what we call r squared. Okay, remember we said r squared, it's the what? It's the coefficient of determination. Remember in our notes, okay, I guess in our notes, is it in this? Yes, I guess it is in this. Remember we said that, and that is model performance. Remember, under model performance we said that we have r squared. Okay, and we said r squared is a statistical method that determines the goodness of fit. Okay, it determines the goodness of fit. Okay, and it measures the strength of the relationship between what? Dependent and independent variable. Okay, but don't confuse it with what? With correlation. Okay, so the value of r squared determines that is determines the less difference between the predicted and the actual value. Hence, the what? Represents a good model. Very correct. Like for example, when maybe we have r squared which is high, like of 97%, okay, it means most of our what? Of our data points are along what? Or they are along or within the what? The straight line. Okay, they are along or within the that is the line, or the regression line. Okay, and this means that 97% of our data, okay, it's what? Was used in this regression, or we can say that 97% of our data, okay, was used in creating this model. Okay, or it was used in this model. Okay, meaning that is most of our data points are within or along that is the regression line, meaning we don't have any that is values which are far away from the what? Which are far away from the regression line. Okay, meaning now the difference between the predicted variable and the actual values is what? It's very small, and you will see that in our analysis, that is it is evident. Okay, because of what? Because of a small what? Standard error. Okay, the smaller the standard error, okay, the good is your model. Okay, the good it's your model. So you can see r squared here. We have a r square of 91.76%, meaning our model used 91% of our what? Of our data points. Okay, so it's like our accuracy, it's above 90. Okay, that is, if we are now to predict, you will find that our accuracy, it's above what? It's above 90, meaning now we will have confidence with our model. But if, yes, someone has a question.
Okay, maybe a question just to know. So, is it on a rare occasion to achieve maybe a 100% goodness rate?
Yes, it's very rare. In fact, even when it comes to confidence level, okay, you will not find any confidence level of 100%. Okay, when it comes to research, for any medical related research or experiment, that is the confidence level should be always 99, should be 99%. Okay, anything less than 99% in medical research, then it might be risky. Like we might not have confidence in your research. Okay, but for other normal research, the confidence is always 95%, meaning anything, if we get an accuracy of 95%, then we are confident of your what? Of your model. And at that point, we usually say maybe that is your model, it's statistically significant. Okay, why? Because at least your confidence is what? It's above 95%. So any accuracy, okay, less than 90, or in fact, in some of the researchers, they usually say for us to have a good model, it should be above 95 or 98%. Okay, so if your accuracy it's more than 95 or 97, then your model it's good, it's almost perfect. Okay, but you can never have a model with what? With 100% accuracy. Never. Even for those who have ever interacted with machine learning, or has ever done a machine learning project, okay, you'll never get an accuracy of 100%. If you get one day, that is an accuracy of 100%, then uh, please share with me. Because it's rare. It's rare. In fact, I've never seen a model with accuracy of 100%. But if you see your model, it's having an accuracy of 90, 92, 93, 95. Yeah, we can consider that model. At least we can say we have 90% confidence in what? In your model. That's okay, Kaka?
Yeah, that's very okay.
Yeah. Okay. Now we have adjusted R square. So for adjusted R square, and that is under simple linear regression, it's always not applicable. Okay, it is always not applicable. But now, when you are dealing with multiple linear regression, it's always advisable to use what? Adjusted R square. Okay, why? Because it allows now the dynamics between, or the difference between what? Between or any adjustments, or it even curbs seasonality in your what? That is within your variables. Like, because remember, we are dealing with what? When we are talking about multiple linear regression, we are talking about that is more than two independent variables. Okay, if you have more than two independent variables, then you will have to consider adjusted R squared. Okay, then for a simple linear regression with only one variable, you can use what? You can use R squared. Okay, then we have the standard error. So for standard error, that is for standard error, you can see it's small. It's moving towards 1. Okay, of course, at least it's not 10, it's not 15, but it's 3. Moving towards the closer, that is the closer the standard error to, that is to 0, the more strong is your model. Okay, so even standard error can show you that is the how good your model is. Okay, all right. Then we have the ANOVA. Okay, so for the ANOVA, we are talking of that is we have degrees of freedom. Okay, and degrees of freedom is always given by that is n minus 1. That is your total observation minus what? Minus 1. That's why you can see we are having a total degree of freedom of what? Of 23. Then we have sum of squared. Then we have mean squared. Then we have f value, that is f value. And then we have significant f or significance f. Okay, remember, we can also use that is significance f. Okay, we shall come now to interpreting this. I have the notes. We'll also go through the notes and get more insight on the same. Okay, so also we usually say, maybe if that is just to measure also the strength of the model, we also have another that is a factor which we can use. Okay, the more this residual, okay, sum of square, residual sum of square, the smaller it is from the total. You can see we have a very big difference between 3376 and 278. So we are saying the smaller, okay, the smaller this residual that is a sum of squared is, also we can say that is the what? The model, it's okay. Why? Because for that is for the residuals, or remember residuals, they are what? They are the vertical deviations. Okay, so the smaller or the smaller the sum of squares of the residual, okay, the what? The better your model. Okay, we can say your model is good. Okay, another one now measure is the significance f. Significant f. So what does significant f do? So remember, we have a p-value. Okay, a p-value is always a standard measure, and a p-value is always of 5%. Okay, so when we say maybe p-value or significant, let's say p-value, let me just go with p-value. So any statistic, it might be a t statistic or f statistic. Okay, these majorly it's they are in distribution. Okay, so the smaller the t statistic or the f statistic, the smaller it is than 5%. Okay, we usually say your model is reliable and it's statistically significant. Okay, so for us, or for our model to be, for our model to be good, then we are saying the f significance, okay, should be less than p-value, should be less than p-value. And the p-value, we usually say p-value, it's scored at what? 5%. Meaning if we get a f statistic which is less than 5% or less than 0.05, okay, the reliable, okay, then it means your model is what? It's reliable and it's statistically significant. Okay, then we have the coefficients. You can see these coefficients are almost the same coefficients which we got here. They are almost the same. They are, in fact, they are the same. When you round off, okay, let me take these values. Let me take these values to here. And then I will round off these values into maybe 3 decimal places. So you can see this value, it is this value, or it's our y-intercept. Okay, and then this value, it's what? This value, the coefficient of what? Of x. Coefficient of x. So you can see the coefficient of the x and also the y-intercept, it's the same. Okay, so you can see we have the same that is coefficients. Okay, yes, so this is the major part, or the part of what? Part of interest. This part, okay, this part. Also, this part will help you when you are doing that is the variance analysis. Okay, variance analysis. That is how your data it's spread away from the mean. And then we have what? We have now this statistics. What? Statistics part. Okay. Cool. Now I want us to go through the notes and see maybe what the notes are telling us. Any question up to that point? All good before we can now go to the notes to do more interpretations. Yes, Kaluki?
Okay, so I wanted to ask, you referred to the p-value and you said that it was standard of 5%,
Yeah,
but
uh,
you
maybe you can repeat that.
so you've referred to the p-value.
Mhm.
And okay, so what I heard was is you said that it's always 5%.
Yes.
And then what I wanted to understand is what does it refer to? What does that, or maybe does the P stand for something, or what does the P value exactly refer to? Thanks.
Okay. All right, no problem. So I will also we'll also discuss that. Okay, let's just first of all go to the notes part of it. Okay, and then now we'll also reach that topic. Okay, and a p-value in that, and I guess we shall get also some points from what? From the notes. Okay, yeah, so I will explain it during that is on that slide. Okay, yeah, so don't worry, I'm trying to find the notes. Okay, so we said that okay, there exist and for different ways to find this. So we did. Now we are here. Okay, that is how to do a linear regression in Excel using the analysis tool pack. And we have taken you through all these steps. That is how to add in the analysis tool pack. Yeah, I still have documented that. Okay, then now how to perform the regression. We still have we still have that is uh, that is the instruction as well. Okay, yeah, that way if you want also the residuals, then you click OK. Okay, now here it's our output. I want us now to discuss on the output. So we've started with we've started with the summary output, all the regression statistics. Okay, now I want us now to start with the multiple R. What is multiple R? I guess we've discussed this. That is the correlation coefficient that measures the strength of a linear relationship. Between what? Between two variables. That's okay. We had discussed that. Then the coefficient, the correlation coefficient can be any value between what? -1 to 1. Of course, we also discussed that. It is an absolute value indicating or it indicates the relationship. Okay, so the larger the absolute value, the stronger the relationship. That means if we have 1, it means we have a very strong positive relationship. If we have what? -1, it means we have a very strong negative relationship. If we have 0, then it means we have what? We have no relationship at all. Okay, so in our that is in our example we got that is a correlation of what? 0.95. Okay, meaning that is one variable that is or we can say variable x explains 95% about what? About variable b. Okay, so they have a very strong what? They have a very strong relationship. Okay, as you can see, this value is moving towards what? Towards 1. Okay, it is moving towards 1. Okay, good. Now let's go to r squared. Okay, so for r squared, it's the coefficient of determination. R squared is coefficient of determination, and we said it's an indicator of the goodness of fit of our model. Okay, basically it tries to show us that is the goodness. Okay, the goodness of fit of our what? Of our model, or how our model fits our what? Fits our data. So we have said that coefficient or r square, it's that is a coefficient of determination, which is used to as an indicator of goodness of fit. It shows how many data points fall on the what? On the regression line. Meaning, in our case, we got 91. Okay, all 0.9, meaning 91% of our what? Of our data points were along what? Were along the regression line. 91%, sorry, of our data points were along the regression line. Okay, so the r square value is calculated from the total sum of squares. More precisely, it is the sum of squared deviations of the original data from the mean. Okay, then in our example we got that is r squared of 0.91. Okay, which shows it is a fairly good model. Why? It means that 91 of our values or our data fit the regression analysis model. Like we are that is 91%. Okay, of our data was used in creating that what? In creating that model. In other words, 91% of the dependent variables are explained by the independent variables x values. Okay, generally r squared of 95% or more, it's considered to be a good fit. So you can remember, I also said at some point that is the goodness of fit. It's a value that is either 95 or more than what? 95%. percent. Good. Now we have the adjusted R squared. So for adjusted R squared, it is the R squared adjusted for number of independent variables. So you can see for number of independent variables in your model. So for your adjusted R, it's mostly useful, okay, under what? Under multiple regression, where we have more than uh, one, okay, independent variable. So you can see it is the R squared adjusted for the number of the independent variable in the model. You will want to use this instead of R squared for multiple that is regression analysis. Then we have the standard error. So we have we are saying that standard error, it's another measure of goodness of fit. It's another measure of goodness of fit. So it is another goodness of fit measure that shows that is the precision of your regression analysis. The smaller the number, meaning the smaller it is moving to zero, the smaller the number, the more certain you can be, that is, you can be about your regression equation. While R squared represents the percentage of the dependent variable variance that is explained by your model, standard error is an absolute measure that shows the average distance, that is distance that the data points that is fall from the what? Fall from the regression line. So you can see the standard error shows us the average distance. Okay, the average distance, meaning maybe let's take this kind of that is model. We have this model with a very large that is we have some data points which are far away from the what? From the regression line. Okay, so definitely the distance, the average distance for this that is model will be what? Will be I. And also from this kind of model, you can see that is the percentage, okay? That is the percentage or less of our data points will be along what? The regression line, okay? So meaning this will be a very poor model. Okay, but let's consider another model, maybe like this. Okay, whereby most of our data points are within the what? The regression line. Only that is small that is data points are of the what? Of the regression line. So definitely for this, the average distance will be what? Will be less compared to this. So the less the average distance, or the less the standard error, okay, the more good, that is the more indicator, or this will have will show that is a better indicator, or it will be a good indicator. Okay, it will be a good indicator of where was I? It will be a good indicator of what? Of our good model. Okay, it will be a good indicator of this model. Good. Then we have observations. Observation, we are saying it is simply the number of observations in what? In your model. It is simply the number of observations in what? In your model. Then we have regression analysis. We have regression analysis. Good. The regression analysis is the second part of what? Is the second part of the output Or the second part of the output is the analysis of variance. Okay, I want us now to check the analysis of variance. So basically it splits now the sum of squares into individual components. Okay, that gives all that give information about what? About the levels of variability within your regression model. We have now degrees of freedom, which is the number of degrees of freedom associated with what? With the source of variance. Then we have SS, that is the sum of squares. Then we have the smaller the residual. Remember, I also said this. The smaller the residual compared to total sum of squares, the better your model fits. That is, fits the data. Yes, it's the same thing. That is, the smaller this value compared to this value, it means the error term it's very small. The error term it's very small. Okay, so that is the better your model is. So this works hand in hand. This will work hand in hand with what? With the that is average distance. That is the standard error. Then we have the mean square, and then we have F. F, we said it's a F statistics, and it's majorly used for hypothesis testing. Okay, F and T statistics are majorly that is used for what? For null hypothesis. And what does null hypothesis assume? The null hypothesis, remember, it assumes that there is no difference. Okay, there is no significant that is significant difference in what you are doing, what in what you are trying to compare. Okay, or there is no effect. There is no effect. This is what? This is the null hypothesis. So F statistic, please now take that is make sure you do what? You keep that is you baking on this, because I'm trying now to connect this with this part where now was it, who was that lady who asked about what is that is the p-value, Kaluki. Okay, I'm moving now to your point. Okay, I'm now moving to your point. Let me just wrap this. Okay, so we are saying that F is a F statistic or F tests for null hypothesis, and it is used to test the overall significance of what? Of the model. So what is the importance of what? Our F test. Our F test, or we are using this F statistic. Okay, I can, it's let me try and see the F statistic formula. It's like statistic, it's like the Z score kind of it. They were okay, we had a relationship that is or there was a relationship between those two points. So F statistics, I guess it's from the student F distribution. I want to try and see if I that is formula. Okay, I can just search it on there. F statistics formula. So this is the F statistics formula. There is a better formula. So for F statistics, you can see it is from F distribution. Okay, we also have T statistic, which is from student T distribution. Okay, so for F statistics, maybe just what I'm interested in is just to check the formula. Okay, to get the formula, maybe for your that is for your information, you can maybe do what you can go and read more, okay, on the F statistics too, to get that is the knowledge. So F statistic is given by the degrees of freedom of some, or that is, this is for, sorry, uh, this is not the correct one. This is for that is the we have right-tailed and left-tailed. Yes, this is the formula. This is the formula for F statistics. So it's like for S, that is for F statistics, you usually take now the ratio of the what? Of the variances of the two variables. Okay, let's say we had one variable. Let's say this is y and this is x. So for you to get the F statistics, you are taking what? The standard deviation of y divided by standard deviation of the second variable, which is x. And here that is, remember that the variance, okay, sorry, I said standard deviation. No, it should be variance because it's sigma squared. Okay, and we are, in that case, we are taking that is the sigma squared of the variance to be summation of x minus what? Minus mu raised to or squared, divide by what? Divide by n, and then divide the two what? Divide the two variables. Okay, and then you will get a value. Okay, a value maybe in decimal, a very small value. Okay, you'll get a very small value. All right, so maybe you can go and learn more about that is the F statistic. But here the objective is F statistics. The good thing now that is Excel calculates it behind the what? Like behind the scene. It calculates it behind the scene. So here we are using F statistics, okay, to test, like to test our null hypothesis. And our null hypothesis basically means that there is no difference or there is no effect. Okay, meaning that we are trying to test if that our model is what? Is good. So we are saying that that is our model has no effect, like maybe it's like kind of a good model. Okay, so, and we are saying that significance F is the p-value of what? Of F statistics. Okay, F significance F is the p-value of F statistics. And what is p-value? So basically, p-value, it's kind of a probability. Okay, and this kind of probability assumes that there is no difference between what? Between your what? Your study. Okay, so p-value, it's a probability, and under this probability we are assuming that that is the null hypothesis odds. In this probability we are assuming that that is the null hypothesis odds. Okay, and maybe just to define, okay, that is the p basically is standing for that is for probability. Okay, it basically mean that is stands for p, that is p, it's probability. It's just an abbreviation of what? Of probability. Okay, and it basically tries to do what? To measure the likelihood, okay, the likelihood that that is the value which we've gotten, and the standard probability, that is the probability will do what? Will maybe will differ. Okay, that's the assumption. That is, the value which we are getting for f significance will differ with the standard probability which is always set. We usually have a set probability like p-value. We always have a set that is a standard value which is 0.05. Okay, and this probability tries to say that, or tries to mean that, there is no significance difference between what within your study. Like for example, if I want to that is to make a study, okay, that is, let me just take example of statistician, that is a statistician, okay, and we have motorbike that is a rider, okay, motorbike rider. We are assuming that this motorbike rider has never gone to school or has never joined college, because I don't want to generalize that, because we also have graduates who are driving what? Who are driving motorbikes. Okay, so I want now to measure, okay, if we have difference in the intelligent quotients, that is intelligent quotient, that is IQ. I want to measure if there is a difference in intelligent quotient, the quotient between what? Between a statistician, okay, and what? And a motorcycle rider, okay, who has never gone, maybe has never gone to college. All right, that's our assumption. Okay, so the first assumption to make, it is the null hypothesis. And what does null hypothesis say? Null hypothesis tries to say there is no difference. No difference in what? In the IQ. So that is the standard that's the standard what? Hypothesis. Like we are trying to say there is no difference in IQ between what? Between that is between the motorcycle rider and the what? And the statistician. Okay, so with that we'll now come and say that is h naught, it's equal to, okay, h naught is equal to the mean what? To the mean of the intelligent quotient. Let's say we have taken a sample of 20 people. We want to measure the intelligent quotient of maybe 20 people. 20 who are that is maybe 10 who are that is statisticians, and 10 who are what? Motorists. Okay, so with that is our assumption is that they are all equal. That is, their average IQ is equal. The average IQ for the what? That is statisticians and the motorist is equal. Okay, but now the alternative hypothesis will try to say what? That it's not equal. Okay, that is their what? Their average, okay, their average IQ, it's not what? It's not equal. Okay, so with that you will have done what? You will have done maybe that is the hypothesis. And my point of concentration is here is the null hypothesis. For the null hypothesis tries to show no effect. Okay, it tries to show us no difference. Okay, there is likelihood that there will be no difference in what? In maybe in the both parties concerned. So Kaluki, p-value basically stands for, that is, probability, under the assumption that there is no what? There is no effect or there is no difference maybe in your study. Okay, yes, that's it. So here our assumption is there is no difference, okay, in what that is maybe in either this model it's accurate or it's not accurate. Okay, we can always say that there is no difference between if the that is if the model will be accurate or not accurate. Okay, yes, so let's now continue. So the ANOVA part is rarely used for a simple linear regression analysis in Excel. Okay, the ANOVA part is rarely used in simple regression analysis in Excel, but you should definitely have a close look at the last component, that is the significance F. And significance F value gives an idea of how reliable or statistically significant your results are. Okay, so we are using significance F, okay, to show us or to give us the idea how your model is what is statistically significant, or how it is reliable. Okay, so if the significance F is less than 5%, which is our p-value, okay, if your significance F is less than 0.5, okay, that is the p-value. And why is this p-value? We are assuming that your model is what is statistically significant. So if the p-value is less than what 0.05, or if the F statistic, that is the significance F is less than 0.05, then it will mean that your model is what is statistically significant. If your significance F or your p-value is greater than 0. What 0.05, then it will mean that your model is not statistically significant, therefore we can't rely on your model. Okay, yes, so if significance F is less than 0.05 or 5%, then your model is okay. If it is greater than 0.05, then you'd probably better choose another independent what independent variable. You better choose another that is another independent variable. Why? Because remember, it's the independent variable which influences your results. Okay, it is the independent variable that influences your output. I hope I was clear. I hope I was clear. If I was, thumbs up. Thank you, Kaluki, Denise, Jesse. Nice. Kennedy, Aini, Wangui, Kanyi, Benson. Oh, that's nice. Oh, how wonderful, wonderful. I've received more reactions. Good. Meaning the point is at home. Then we have regression analysis output. Okay, so for this we are just going to concentrate on the what? On the coefficients. And you can see if you have now the coefficients, you can now create your model. So you can see we are dealing with average monthly rainfall and the umbrella cells. So you can see this is our model. We are trying to predict Y. Remember why it's the what? It's the umbrella cells, sorry, and it will be given by the rainfall coefficient multiplied by what x plus the intercept, and these are the values which we did what which we got, and this is our model. The way I guess we've been doing this, that's why I'm just jumping this. Okay, Then we have that is how to make a linear regression using the graph. Also, we discussed this. Remember, we also did this. Okay, we also did this. We also did this. Okay, we also did this. We also did this. We also did this. So the last method, so that we may close on the topic. So I want us now to use now that is Excel inbuilt that is functions to compute what we need, what the slope, okay, and we need the what the y-intercept. Okay, so in Microsoft Excel we have a few statistical functions. So we have that is linst, I don't know, linst function, we have slope, and we have intercept, and we have what correl. Okay, and linst that is function, it uses the least squares method, regression method, to calculate that is a straight line that best explains the relationship between what between your variables and the return. So definitely this will give us the slope. If we use this formula, it will give us now the slope, okay, and the what and the intercept at once. Okay, you can as well now go and use slope function and use intercept function, okay, also to find the values of what the values of our constant separately. Okay, yes, and then you can just read all this maybe again to do what to just to follow up, okay, but it's almost the same thing. I'm just going to do the practical part of it, where we'll use those three what these three that is formulas, links it, and then we have intercept, and we have slope, and see if we are going to get the same what the same output. So here we need slope, we need intercept, and also we have another function which can give us these both. Okay, so let's try and use that that is linst what linst that is formula, and you can see it returns statistics that describe a linear trade matching non-data points by fitting a straight line using the least square method. So we'll use this function. Then what do we need? We need only the y nonce and the x nonce. Okay, so the y nonce, will start with the y nonce, that is the range of all the y values, and then we also need the values of what the values of our x or the x nonce. When I run these, I will get two values. Okay, you can see I got two values. That is the slope. You can see in this case I got the slope, and I got the what the intercept. The same values which we got here, you can see these are the same values which we got here, and they are the same values which we got here. They are the same values which we got here, right? Meaning we got the same thing. Then the other formula to find also the coefficients is to use the slope and use the what intercept function. So we are going to say equal to slope. Okay, we have that is function, and slope will return the slope of the linear regression line through the given data points. Okay, so we are going to use slope, and for slope we are going to use what the non y's and the non x's. So of course we are also going to highlight the what the range for non y's, and also range for the non x's. Once you run, you are going to get the value of what of the slope. So you can see this is the same value as this, and also the same value we got. Okay, slope. Then we have intercept. For intercept, we are going to use the function known as intercept. Okay, and intercept, you can see we also are going to use what? The non-y's and the non-x's. So with that, we are just going to highlight the range of all the non-y's. Okay, then comma, then the non-what? The non-x's. Okay, then run. If you run, you can see we are getting the same value, intercept value we've been getting all through. Yes, and that's all about the three methods of what? Of finding the coefficient of what? The constants, sorry, or the coefficients of the regression that is regression line equation. Okay, yes, that's all for today. Any question?